Hello everyone, welcome back to the channel. I hope you guys are doing really well. So we will see today's daily challenge on Leetcode and try to solve it together. And today's challenge is a really simple one. So we will try to understand the problem statement at first. So maximum number of operations to move ones to the end. Okay. So this time you need to maximize your operations, not minimize it. You will be given a binary string s which will contain only 0 and 1. You need to choose an index I from the string such that s of I is 1 and s of I plus 1 is 0, and also s I plus 1 should exist. And you need to move the character this to the right until it reaches the string end of the string or another one. So for example, if you are selecting this pair 1 comma 0 s of I 1 and s of I plus 1 0, then this one will be moved until it encounters another one, that is this just before this. Okay, so you will see that there will be 3 zeros now and 2 ones together and a 0 at the end. I hope you do understand how one operation is performed here. You need to find the maximum number of operations you can perform, and it is quite obvious that at the end of all operations all of the ones will be on the right side. Okay, so as you can see here, it is told that first you could have chosen this particular index and the resulting string would be something like this 0 0 and 111, and then you could have chosen one by one this one to shift it to the rightmost, then again this one to shift it to again the rightmost, and this one. So in a total of 4 operations you would have made all the ones to the right. Okay, so how to maximize the operations, that there comes the interesting portion. So if you try to take an example of something like this. Okay, let's say you have got a string which looks like this. Okay, so you want to convert this string to something like this 0 0 0 1 1 1. Okay, so how many maximum number of operations can you take? So one thing, first of all, if you try to order matters here. Okay, so if you try to choose these two index first, okay, and try to convert this is s of I 1 and s of I plus 1 0. So in the next operation it would have looked something like 0 0 0 1 1. Okay, and in the next operation if you would have chosen these two elements and chose to transfer this one to the right, it will be like something like this, and in 2 operations you would have reached your answer. Can you do it in larger number of operations? You see, if you would not have transferred this first, instead try to transfer this to right. Okay, so let's say you choose these two elements first, then you would have got something like 0 1 1 0 0 1. Okay, and then now you choose this element to move to the transfer it to the right, so you will get this, and then again you choose this element to transfer to the right, you will again get this. So now you see you performed 1 2 3 operations right now. Okay, so your answer is 3 in this case. So what did you learn from this example? It is quite obvious that you should move uh, the rightmost ones first. Okay, the rightmost ones first. In order to maximize the operation, you should move the rightmost ones first. Okay, so I hope that much understanding is very clear and easy from this explanation. Yeah, that only we need to do, otherwise the operations will be minimized. Now how exactly will we calculate the answer? Okay, now if you try to think it in this way, that there is a clump of ones, okay, and there is some zeros in between, then there is again some clump of ones and there is again some zeros in between, there is again some clump of ones, let's say 4 ones this time, again some zeros in between, and there is, let's say, 2 ones at the end. Okay, so if you try to look at this problem, what will be the answer? You see, there are 3 ones here, there are 2 ones here in this set, there is 4 here, and there is 2 at the end. Okay, so as you know that at first we need to move the rightmost ones. So if you see, if you try to move shift this one over here, then again next operation you will shift this one over here, next operation you will shift this one over here. So you will take 3 operations, right? That is equal to the number of ones. So after that you will be remaining after 3 operations, okay, after 3 operations you will be getting some results like 0 0, 1 1 1 1 1 0 0 1 4 ones and something like this. So you see this 3 and 2 get clumped together and form 5, and this 4 and this 2. Now in the same way you could have transferred this one, then this one over here, then this one over here, and then so on like that. Okay, so again it will be equal to the number of operations, a number of ones, number of operations will be equal to the number of ones. So now with 5 operations, you could have transferred this 0 0 and 3 more zeros and total of 9 ones. Okay, so there will be 9 ones and 0 0. Now again with 9 operations you would have got all zeros in the front and all ones at the end. I hope that is very clear to you. So how many operations you need? Maximum 3 plus 5 plus 9, which is nothing but 17. Okay, so I hope that is very clear, and you observe some pattern. Okay, so at first you add 3 to your answer. Okay, at first you add 3 to your answer. Okay, then you add 3 plus 2 to your answer, that is 5, right? That's what we are adding, 3 plus 2. Your array is looking something like 3 2 4 2, right? If you try to form an array with the clump of ones, it is looking something like this. And it's 3 plus 1, you add 3 plus 1 3 to your answer, then 3 plus 2 to your answer, then you add 3 plus 2 plus 4 to your answer, which is nothing but 9, right? So at first you add 3, then you add 3 plus 2 to your answer, and then you add 3 plus 2 plus 4 to your answer. That is nothing but 9. Okay, so you add 3 plus 2 plus 4 to your answer, and the sum of all these 3 times. So basically you do 3 multiplied by 3 times, 2 multiplied by 2 times, 4 multiplied by 1 times is equal to what will be your answer. That is your final answer, which is nothing but 17. Okay, so in general you can definitely write a formula for this, right? So 3 2 4 2, let's say for this one, the thing is that you do not need to consider whichever element is present at the last. Okay, so if there is something like 3 0 0 1 1 1 0, okay, then in order to shift these two elements at the last, I am considering this at the last bit of elements. Okay, and in order to shift them to the last, you need something. But if already you have ones, 2 ones, something like this, okay, then you do not need to worry about shifting these two. Okay, so yeah, whatever be the case, you can choose to form your array like that. You do not take the last clump of ones if they belong to the belonging to the last set of elements. Okay, so 3 to 4 you see is the thing, and 3 multiplied by number of elements. So number of elements in this array is 3. So 3 multiplied by 3, that is the number of elements, plus 2 multiplied by the number of elements minus 1. So index number of 2 is 1. So number of elements 3 minus 1, and 4 multiplied by number of elements minus 2. That's what is the general formula which you are getting, and you can simply write a code for this, and I hope that will be very simple. You could have you should be able to now pause the video and write the whole code on your own also, but anyways we will talk about that, and we will just solve it. Okay, so let's see, we need to have a vector which we will use to store the elements, right? And we need to have a count which will be initialized to 0 at the first, and I will go through all the elements s dot size. Okay, and yeah, I have it. And if I see that s of I, current s of I is something like 1, then it is simple operation for this. I will just increment by my count by 1. Else I will check that else it means that s of I is 0, right? I should reset my count to 0. But before that I should also do vector dot push back my count. I hope you do understand that in this way all my clump of ones will be stored, but in this vector. And but if count greater than 0, I don't want any 0 elements in my answer, right? So then only I will push back this count. And you see automatically if there is an element, you see if at the end of the vector it is something like 1 1 1 and the vector is getting ended, okay, 0 and some 1 1 1, then this will not be stored in this particular vector, which we actually want to happen. And if there is a 0, because only when it encounters a 0 it will try to store its previous count. See, now currently CNT is equal to 3. If it gets a 0, then only it will try to push back this vector count, this count into the vector, otherwise it will not push anything, okay. So I hope that is very clear, and that is what we wanted to happen. And now we can simply do that, keep multiplying the elements and adding to the answer. That will do all. So answer is equals to 0, and we will want to iterate through our vector v of size. And what we will like to add to our answer is very simple: v of I, the first element, multiplied by v dot size minus I. Okay, I hope that was clear to you, because for the first element, if the size is 3, for the first element we multiply by 3, then 2, and then 1. Okay, so that's what, one by one it is decreasing, v dot size minus 1. And you can simply choose to return answer. That will be all for this problem. If you try to run it, I guess it will work just fine. Yeah, it got accepted. If you try to submit for all the cases, I hope it will also work just fine, and a simple O of one time complexity. Okay, yeah, it was giving me a better runtime complexity when I was running it with the same code. You see 83% bits, which is quite decent. And if you analyze the complexity, it will be something like O of n. Okay, so I hope that is very simple and easy to do. Yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.